So in this video, I am going to discuss longest path matrix algorithm that is used to calculate iteration bound for any recursive DSP system. So steps involved are: step number one, you have to calculate series of matrix LM where M is equal to 1, 2, 3 up to D, and D is total number of delay elements present in the DFG. After creating that matrix LM, you have to examine their diagonal elements, and by using the elements present in the diagonal of LM, you calculate iteration bound that we will see. So to calculating LM, so order of LM, this matrix LM is D cross D. So if suppose D is 4, so order of matrix will be 4 cross 4, and you have to create total. M will be equal to, in this case, 1, 2, 3, 4. So you have to create matrix L1, L2, L3, L4, and order of each matrix will be 4 cross 4. So it will have 4 columns, and it will have 4 columns and 4 rows. Okay, so now you have to calculate these elements of this matrix. So this is denoted by small l, I comma j, m. This is I comma jth element of matrix Lm. So it is defined as longest computation of all path from delay di to dj. Okay, we are calculating the value of li comma j. So it is the longest computation of all path from di to dj that pass through exactly m minus 1 delays, and di and dj are not included. So you have to find a path following this condition in the DFG, and if no such path exists, then li comma j m is minus 1. The value of I comma jth value for this matrix will be minus 1 if this condition, first condition, is not satisfied. So using these steps, we will calculate iteration bound for this given DFG. So D in this case, small d, is 4. So we have to create matrix L1, L2, L3, and L4, and order of each of this matrices will be 4 cross 4. So first you have to create matrix L1, and order will be 4 cross 4. Suppose this structure of matrix L1, and I represents rows 1, 2, row 1, 2, 3, 4, and J represents column 1, 2, 3, 4. And so now you have to calculate L1 I comma j. This is small. And how it will be defined? L1 I comma j, it is defined as longest computation for all path from delay di to delay dj that pass exactly that pass through exactly m minus 1. This thing is important, m minus 1. So m is 1, so 1 minus 1, m minus 1, that is 1 minus 1 is 0. So that pass through exactly 0 delay element, 0 delay element. So this can be computed directly from the DFG. This can be computed directly from the DFG. From the given DFG. So to calculate the I comma jth element for L1 matrix, we will use this DFG directly. So now we will calculate all the elements one by one, starting from 1 comma 1. So this is delay element Di, this is delay element Dj, and here I have named the delay elements. This is D1, D2, D3, D4. Calculate 1 comma 1. I have to find the longest computation of all path that originates from D1, passes through 0 element and ends at D1. So this path is practically not possible. So no such path exists. In that case, the value is minus 1. Calculating 1 comma 2, 1 comma 2. So there is a direct path between 1 and 2. There is a directed edge, so there is a directed path. This is the direct path from 1 to 2, and there is no computation element present. So computation time is 0, and there is no alternative path from 1 to 2. So in that case, we have started from D1, we have traveled to D2, and no other delay element was in between, and computation time is 0. So the value of 1 comma 2 is 0. Now 1 comma 3. So start from D1 and you have to travel to D3, and no other delay element should come in between. So start from D1 and you have to go to D3, and no other element, that is D2 and D4, should not come in between. So here you can see that D2 and D are in the path. You cannot go from D1 to D4, sorry, D3 directly. So no such path exists. So in this case, the value is minus 1. And same can be said about path between D1 and D4. No such direct path exists. So the value is minus 1. So in a similar manner, we can find other elements. So now calculating for 2 comma 1. So D2, I have to start my journey from D2 and I have to reach D1. Okay, so from the DFG you can see that this is the possible path. Starting journey from D2, visiting node 4, then node 2, then node 1, and then D1, and no other delay elements, that is D2, D3, D4 were in between. So you have to add their computation time. Computation time is written in the bracket, that is 2 plus 1 plus 1. This is 4. Okay, So you have to look for alternative path also, and you have to select the maximum one. If such, if there any other alternative path exists, perform the calculation in the similar manner, and if that value is greater than this, select that value. So here you can see that there is no alternative path from D2 to D1. Okay. There is, but it is having a delay elements D3 and D4, and we don't have to include these, any of these delay element. So 2 comma 1 is 4. 2 comma 2, I can directly say that this is not possible, so I can directly write its value as -1. 2 comma 3, 2 comma 3, there is a direct path and no other computation element is involved. This means that computation time is 0. The data generated by D2 will be immediately transferred to the input of D3. So the value of 2 comma 3 is 0. And 2 comma 4, 2 comma 4, no path exists, D3 is in between, so value is -1. Now we can calculate 3 comma 1 also in the similar manner. So 3 comma 1, so you have to start your journey from D3, and it seems that one path is possible. D3 to node 5, node 5 to node 3, node 2, node 1, and then D1. 5, 3, 2, and 1, and then D1. Okay, and adding their computations time, so 2 plus 1 plus 1 plus 1, this gives 5. So value is 5. Calculating for 3 comma 2, 3 comma 2 is not possible in any way, so value is -1. 3 comma 3, directly I can write -1, because there is no way you can start your journey from 3 and you again reach the same point. 3 comma 4, direct edge without any computation element in between, so value is 0. Now calculating for 4 comma 1, D4 to D1, one path exists. So D4, then node 6, node 3, 2, and node 1, and then back to D1. Adding their computation time, 2 plus 1 plus 1 plus 1. This gives 5. 4 comma 2. Now you can very quickly you can say that no such path exists. It is just a matter of practice. -1, 4 comma 3, no path exists, -1, and 4 comma 4, not possible, again -1. So this is how L1 is created from the DFG directly. Now you have to create matrix L2, L3, and L4 in this particular order. First you will create L2, then L3, then finally L4. So unlike L1, these higher order matrices L2, L3, and L4, so these higher order matrices Lm for m equal to 2, 3, 4, L2, L3 and L4 need not to be determined directly from DFG. So to calculate the elements of L2, L3 and L4, we will use this mathematical formula. This is a kind of a recursive formula because Li comma j for m plus 1 is depending on Li comma k comma j of m. So earlier I have told that if a function depend on its own past value, so this is the element of m plus 1 matrix, this is the element of mth matrix, so it can be said as present value, past value. So this kind of relation is a recursive relation. So we will use this mathematical formula Li comma j m plus 1 we are calculating for m plus 1th matrix, assuming that we have calculated till Lm, and it is max small k dash belong to a set of values that is capital K, and capital K is a set of integers from 1 to d, where d is number of delay elements. So in our case delay elements are 4, so capital K is a set of integer 1, 2, 3, 4. So small k will be one of these values, either 1, 2, 3 or 4. So you have to calculate Li comma k, and this will be taken from matrix L1. This will be always taken from matrix L1. This is Lk comma j, this will be taken from matrix M, one matrix previous to m plus 1, and then you have to take maximum of minus 1 or these two values. So before performing this addition, you have to check whether Li comma k is not equal to minus 1 and Lk comma j should not equal to minus 1. This is the criteria for selecting k. So using this relation, we will calculate the elements of matrix L2, and we need matrix from, and we need elements of matrix L1. So I have written L1 over there, and I have to calculate L2. The size of L2 is also 4 cross 4, and equation with respect to L2 looks like this: L2 I comma j equal to max k belongs to 1, 2, 3, 4, maximum of minus 1, or Li comma j of matrix 1 plus Lk comma j of matrix 1. So for L2, both the elements will be taken from matrix L1. So this is always taken from matrix 1, and this is taken from the previous matrix. So for 2, the previous matrix is also 1. So starting with 1 comma 1, L2 1 comma 1. So this will be maximum of k 1 comma 2 comma 3 4 minus 1, or L1 comma k matrix 1 plus L k comma 1 of matrix 1. So the value of k varies from 1 to 4. So L1 comma k, 1 is fixed here. This means row 1 is fixed, and Lk comma 1, so row is varying, column is fixed. Column 1, that is 1, is fixed. In this case, row is fixed, that is 1. We have to check in different columns in row 1, and in this case column is fixed, k is varying, so we have to check in different rows for column 1. So for k equal to 1, k equal to 1, this is, this term is L of 1 comma 1, and this term is also L of 1 comma 1. So L of 1 comma 1 is negative, it is minus 1, it is minus 1, so you don't have to consider the minus stuff, so no need to calculate for k equal to minus 1. For k equal to 2, this term is L1 comma 2, and this term is L2 comma 1. So 1 comma 2 is this term 0, it is positive, and 2 comma 1 is 4, both are positive, so we can calculate this. So 0, L1 comma 2 is 0, L2 comma 1 is 4, that is final answer is 4 for k equal to 2. For k equal to 3, we have to calculate L1 comma 3 plus L3 comma 1. So 1 comma 3 is negative. Even if one term is negative, you don't have to uh, check for the next term, because you don't have to consider if any of the Li comma k or Lk comma j is negative, so discard this. For k equal to 4, L1 comma 4 plus L4 comma 1, so 1 comma 4 is negative, again negative, I'll discard this. So you have to choose the maximum value. So this is minus 1. Result of this calculation is 4. You have only one choice, 4, because for k equal to 1 not valid, for k equal to 3 not valid, for k equal to 4 this is not valid, only for k equal to 2 it is valid. So out of minus 1 and 4, you have to choose max, and obviously 4 is the maximum value, so the result is 4. So using the same approach, I can calculate any other elements of matrix L2. So I am calculating for 1 comma 2. So the formula will be something like this: L of 1 comma 2 for matrix L2 is maximum of minus 1, L 1 comma k, so I is 1, so 1 comma k plus L k comma 2, so j is 2 in this case, so this is k comma 2, and both will be taken from matrix 1, and k belongs to 1 2 3 4. So again, following the same approach, starting from k equal to 1, so this becomes L 1 comma 1 plus L 1 comma 2, so 1 comma 1 is this term, negative, 1 comma 2 is second term, this is positive, so 1 comma 1 is negative, this selection is invalid, no need to check for second term. So this is a matter of practice, this computation will be very fast, this is the matter of practice. K is equal to 2, for k equal to 2 it becomes L 1 comma 2 plus L 2 comma 2, so 1 comma 2 is 0, this is 1 comma 2, and 2 comma 2 is negative, invalid. So for k equal to 3, L1 comma 3 plus L3 comma 2, so 1 comma 3 is negative, invalid, no need to check for second element. And for k equal to 4, L1 comma 4 plus L4 comma 2, so 1 comma 4 is again negative, so no need to check, so no value of k is valid, so this is invalid, so only minus 1 is remaining, so the value of 1 comma 2 is minus 1. So now I will calculate for 3 comma 1. So formula will be like L of 3 comma 1 of matrix 2 is equal to maximum of minus 1 comma L of 3 comma k of matrix 1 plus L of k comma 1 of matrix 1, and we have to perform the same computation again and again. So starting from k equal to 1, check L of 3 comma 1, 3 comma 1, this is 5. L of 3 comma 1 plus L of 1 comma 1. So L of 3 comma 1, 3 comma 1 is 5 and 1 comma 1 is negative, so invalid. One element is negative. So k equal to 2, L of 3 comma 2 plus L of 2 comma 1. So L of 3 comma 2 negative, invalid. No need to check for L of 2 comma 1. K equal to 3, it is L of 3 comma 3 plus L of 3 comma 1. So L of 3 comma 3 is negative, invalid. And for k equal to 4, it is L of 3 comma 4 plus L of 4 comma 1. So L of 3 comma 4, check L of 3 comma 4, this is 0, positive, and L of 4 comma 1 is 5. So the result is 5. So these three are invalid. For k equal to 4, the result is 5. So obviously this is the maximum and 5 is the value. So by using this approach, you can calculate all the values. I am not calculating for each and every terms. You can use this approach, and if any one of the element is negative, the value of that k is invalid. You just have to select non-negative elements. Okay, so I am writing the remaining elements. This is will be 0, minus 1. You have to verify it by solving it yourself. So this one, this will be 0, 5, minus 1. This will be minus 1, 5, minus 1, minus 1. So you can verify it by solving it yourself. This is a matter of practice. The more you will practice, the more faster you will be able to solve it. So L1 and L2 is calculated. Now we have to calculate L3 by using the elements of L2 and L1. So formula for L3 will be something like this: small l of 3 I comma j is maximum of minus 1, L of I comma k of matrix 1. So this is from matrix 1, and L k comma j of matrix 2. So this is m plus 1, that is 2 plus 1. This is 3, and m, this is m. So it will be taken from L2. This will be always taken from L1. So calculating L of, I will calculate few elements. So calculating L of 1 comma 1 for matrix 3, this will be maximum of 3, 4, minus 1, L of 1 comma k of matrix 1 plus L of k comma 1 of matrix 2. So 1 comma k, this is row 1, 2, 3, 4, this is column 1, this is row 1, 2, 3, 4, and this is column 1, 2, 3, and 4. So L of 1 comma k plus L of k comma 1 you have to perform for different values of k. So starting from k equal to 1, check L of 1 comma k, it is negative. L of 1 comma 1 plus L of 1 comma 1, this is negative. L of 1 comma 1 of matrix 1 of this is of matrix 2, so invalid. Now checking for k equal to 2, so elements are L of 1 comma 2 of matrix 1 plus L of 2 comma 1 of matrix 2. So L of 1 comma 2 is 0 and 2 comma 1 is 5. So the answer is 5, valid. For k equal to 3, L of 1 comma 3, so L of 1 comma 3 you can see that it is negative, so obviously this will be invalid. K equal to 4, it will be L of 1 comma 4. L of 1 comma 4, it is negative, no need to write second term, invalid. So the more you will practice, the more you will be able to calculate this faster. So the answer is the answer is 5. So calculating for L of 3 comma 1, I have to check L of 3 comma k for different values of k, and then I have, this is from matrix 1, and then I have to check for L of k comma 1 of matrix 2, and I have to add them. So for k equal to 1, this is L of 3 comma 1 of matrix 1 plus L of 1 comma 1 of matrix 2. So 3 comma 1 is 5 and 1 comma 1 of matrix 2 is 4. This is 9. For k equal to 2, this will be L of 3 comma 2 and this will be 2 comma 1 of matrix 2. So 3 comma 2 is negative, invalid. For k equal to 3, L of 3 comma 3 plus L of 3 comma 1 matrix 2. So L of 3 comma 3 is negative, invalid. And for k equal to 4, L of 3 comma 4, so check, you can check 3 comma 4, this is 0, okay. L of 4 comma 1, L of 4 comma 1 is 5. Okay, so this is 3 comma 4 is 0, 3 comma 4 is 0, and 4 comma 1 is 5. So 0 plus 5, this is 5. So you have -1, 9 and 5. These two are invalid and you have to choose maximum from this. So 9 is maximum. So L of 3 comma 1 is 9. So using the same approach you can calculate other elements. I am writing down directly. You can practice and verify it. This is 4, -1 0, and 2 comma 1 is 8, this is 5, 4 minus 1, this is 9, 5, 5 minus 1, and this is 9 minus 1, 5 minus 1. So in the same way you can calculate elements for L4 and the values are written over directly. You can verify it by solving the equation. So we have calculated all the four metrics L1, L2, L3 and L4. After that, iteration bound can be calculated by using formula. This is the symbol of iteration bound. Iteration bound is maximum of I, comma m belongs to 1 to till d, L of I comma I of matrix M divided by M. So in this example, d is 4. So M is 1, 2, 3 and 4. So value of M will be 1, 2, 3 and 4. So L I comma I of matrix M. So this means this is a diagonal element. So you have to check the diagonal elements of all the matrices and divide the diagonal element by M. So for L1 M will be 1. So for L1 M will be 1. For L2 M will be 2. For L3 M will be 3 and for L4 M will be 4. Divide their diagonal element by respective values of M. Positive values. You don't have to take negative values. So all the diagonal element is negative. Here 4 is positive and M is 2. So 4 by 2 from this matrix and again 4 by 2. Here M is 3 and diagonal element is 5. So 5 by 3, 3 times 5 by 3 and 5 by 3. Here M is 4 and diagonal element is 8, 8, 5 and 5. So 8 by 4 by 4, 5 by 4, 5 by 4. So all the diagonal elements divided by their respective M values is written here and you have to select the maximum out of this. So maximum is 2. This calculation can be done easily. So final iteration bound is 2 unit time.